Hi, my name is Keith Schilling. I'm the State Geologist of Iowa and the Director of the Iowa Geological Survey at the University of Iowa in Iowa City. At the Iowa Geological Survey, we've been involved with several Iowa Nutrient Research Center projects over the past few years. And to characterize all of these projects, or some of these projects together, what we've really been focused on is essentially following the water and the nutrients across the landscape from the edge of the field to the rivers to identify locations on the landscape where naturally occurring nutrient processing could occur. And there's also opportunities that we're investigating to enhance that processing capacity through new design elements or better incorporation of the subsurface into the pathway. You know, one of the first things we're looking at is, and especially in the rolling countryside across much of Iowa, farm fields are bisected by a lot of grass waterways, which are these, again, vegetated strips in the fields that convey surface water runoff from the field to the stream. However, what we've done is looking at the subsurface processing capacity of these waterways. They're natural collection areas for eroded sediment, high in organic matter to accumulate. They tend to have high water tables, and they're also tile drained, unfortunately. But this natural setting of high organic matter material, saturated conditions, low dissolved oxygen are just conditions ideal for nitrate processing through processes like denitrification. We've investigated grass waterways at the Kirkwood Community College location in outside of Cedar Rapids in Lynn County. Kirkwood maintains a large agricultural farm. If you didn't know, they're the largest two-year ag program in the country. So they have fields that we are allowed to use to investigate this, and through the cooperation with their staff, we installed monitoring wells in these grass waterways. We documented nitrate concentrations in the upland fields compared to the waterway, and we show a 60% reduction in nitrate concentration. Through modeling of groundwater and so forth, we're able to document that there is a significant nitrate load reduction, which is the total mass reduction that is equivalent to things like saturated buffers and bioreactors. We're starting to develop the design criteria that we could work with to enhance the capacity of waterways for nitrate reduction. So similar to a saturated buffer, which are connecting tile drainage back to the riparian buffer, perhaps there's a way to reconnect tile drainage that typically drains the waterway with the waterway sediments and develop a practice something like a saturated waterway, where we could gain some nitrate processing in these natural areas. In a second INRC project, we have focused on following the water from the edge of the field into a roadside ditch. So in this case, the roadside ditch is the primary pathway for water and nutrients from a field into the river. Our work is focused here in eastern Iowa in the Lime Creek watershed, which is a small watershed between Cedar Rapids and Waterloo. In this area, we've mapped out the flow paths, and we determined that 30% of the watershed actually drains to a ditch before it gets to a stream. And what we found here is that the roadside ditches reduce the nitrate concentrations by 60% and have a load reduction equivalent to many wetlands in the state. Follow the water downstream further, you get to floodplains and Oxbow Lakes. Oxbow Lakes are these little arc-shaped lakes that formed as meandering rivers get cut off in the main channel. Oftentimes they filled with sediment, and they no longer function as a lake. What we've done is work closely with our partners from the U.S. Fish and Wildlife Service, the Nature Conservancy, and the Soybean Association to reconstruct these oxbows, primarily for important fish habitat for an endangered species called the Topeka shiner. Through work funded by the INRC were able to document the water quality benefits of these reconstructed oxbows, in particular in locations where they're fed by a tile drainage. So in this case, tiles will feed into an oxbow, delivering higher concentrations of nitrogen and phosphorus. And our work through the INRC has allowed us to document that these oxbows do a very effective job for nitrate reduction. And comparing tiled fed versus non-tiled oxbows. And both of them do a great job of nitrate reduction. It's just the tile fed ones see more nitrate load instead of just a random overbank flood. And so through partnerships with Iowa State University, who led the efforts to look at the fish and habitat monitoring, we have found that the reconstructed oxbows that received tile drainage really were no different in terms of habitat compared to the non-tile fed oxbows.